my name is Sung. I'm with the IT Monkeys, Tobias, Jesus, and Isaac. We're going to be presenting our UML models for our Timekeeper application. And to recap, our Timekeeper application's goal is to provide an easy solution for contractors and business owners to manage employee hours. And UML models, or the Unified Modeling Language diagrams, offer a more clear and accessible way to analyze and design software. So to start, here we have our use case diagram. And the use case diagram in UML is a visual representation that shows the interaction between the users or actors and the system itself. It captures the functional requirements of a system, showing how different actors interact with the same system. We have a big rectangle representing the system boundary. So within that system boundary, we have all of our methods, and then outside of that, we have our actors. We have a manager actor, an employee actor, and our GPS service actor. And you can see the lines connecting them to which methods they would be using within our application. So the employee and the GPS service would help with clocking in and clocking out. The employees can view their schedule, their payroll report, while managers can create and edit schedules, assign employees work sites, approve hours, and generate their payroll reports. And next up, we have our domain class diagram. And so in UML, the domain class diagram represents the behavior of the object within the system. They are used to model the structure and behavior. They define the class attributes, the methods they can perform, and the relationships between them. So at the top, we have our superclass user with the attributes user ID, name, email, and phone number. And we have two different types of users. We have the employee and the manager, which you can have many of both. For manager, we have the manager ID, and then under that we have its methods: make, edit schedule, export payroll, approve time log, add and subtract employees. And then for employee, we have position, hourly rate, tax data, and they're going to be able to view their schedule, clock in, clock out, add, edit their tax info, and view their pay reports. And then we also have a worksite class, report class, schedule/calendar class, and a time log class, all with the appropriate attributes and methods that help us achieve our business problem.
All right, and next we have the activity diagram, which is basically a flow chart that visualizes how a system works step by step. Maps out how the process starts, the decisions made along the way, and how they end. And the purpose of this activity diagram is to show how the timekeeper system works step by step, from when a user starts their workday to when they clock out. So it basically outlines a workflow of activities, decisions, and data handling. So this I divided into four main lanes. You have the user lane, which are the actions performed by the employee. You have the task management lane, which is where the system handles task creation and updates. The storage layer manages how data is stored either locally or in the cloud. And finally, we have security and utility, which handles the GPS verification, calendar sync, data encryption, and exporting to an invoice system. So the process begins when the user clocks in. The system checks if the user is online, and that's the first decision point. If they're online, the data syncs to the cloud, or if not, it's stored locally until a connection is available. At the same time, GPS verification confirms the user's location, and the system may sync with the calendar. Once you're clocked in, the user can manage tasks such as adding, editing, deleting, or categorizing tasks. They can also create subtasks or set recurring tasks. They can also link them to a specific client or job. This diagram also shows the idle states, like when they're logging a break and later resume their work. When the user clocks out, the system encrypts the data, syncs it, and then exports it to for invoicing. And that is where the process ends at the end workday node, which completes the full daily workflow.
All right, and then we're going to move on to the system sequence diagram, or in short, SSD, for the clock in use case, just to show an example. And so this diagram shows the interaction between the worker, the timekeeper system, and the GPS service during that clock in process. And so when the worker initiates the process by opening the clock in screen, the system requests the device latitude and longitude, so the coordinates, from the GPS to verify the worker's location. Then, after receiving the coordinates, the worker submits the clock in information, including the job ID, the location, maybe even a photo just to verify for the employer, and then also a timestamp to see when that happened. And then the system validates the data and confirms a successful clock in. If the device is offline, then the record is automatically synchronized with the cloud. If it's offline, it is saved locally and then synced later when back online. And then we also have alternative paths that alternate path handle cases where GPS is disabled. For example, the job ID is invalid or the worker is outside the job's geofence, so outside the predefined coordinates. And the diagram basically highlights the logical flow of messages that ensure reliable and accurate time tracking within the Timekeeper app. And down there, you can see a little link where that information came from. And yeah.
And this is our state chart diagram, which shows the different states the program or object can be and how it moves between them. The first state is idle, and then it branches off from there into two, just the normal clock in, and then a GPS time start. And then they merge back together when they start the timer, and then there's an exit case where the user tries to pause the timer and resets the timer. And then there's the end timer state, as well as the store time state, and then the final state, which loops back to the beginning.
Okay, and then for the conclusion, UML models or unified modeling language diagrams offer a more clear and accessible way to analyze and design software. This week we used the UML use case diagram, the domain class diagram, the system sequence diagram, the activity diagram, and also the state chart diagram to bring our project analysis phase to an end or to a closing. And now we are sure that we are fully prepared for the next phase, which will be the most interesting phase, the development phase.
Thank you. See you next week. Bye.